This video is part 2 of the section 8.6 video, and in this section we're going to be deriving the vertex formula. Basically what we're going to be doing is trying to find the vertex form of a generic quadratic equation. That's going to give us a formula for finding the vertex. So we start out with our generic quadratic equation, y equals ax squared plus bx plus c. We go ahead and walk through our steps for completing the square. I start by subtracting c from both sides, which gives me y minus c equals ax squared plus bx. Now, we also need to get that a out of there, so we're going to divide everything by a. That gives me y minus c, I think I'm going to leave that all over a for now, equals x squared plus b over a times x. Now, in completing the square, the next step is to find the magic number and add it to both sides. So I take the coefficient from x, which is b over a, and I want to divide by 2. Remember that dividing is the same as multiplying by the reciprocal. So this is the same as b over a multiplied by 1/2, or b over 2a. Now, to get my magic number, finally, I want to square it. So I want to take all of this and square the result, which gives me, I'm just going to leave it as b over 2a squared, and we'll worry about exactly where that goes later. Now we add that to both sides of our generic equation. So I have y minus c over a plus this magic number, b over 2a squared, equals x squared plus b over a x plus b over 2a squared. Now that we have this cute little equation, we're going to try to factor it. Now remember that this had better be a perfect square because we added the magic number. Remember that when you factor your perfect square, what you end up with is always x plus your magic number before you squared it. So this is x plus b over 2a squared. So now I have this equation, y minus c over a plus b over 2a squared equals x plus b over 2a, quantity squared. Our next step after we've completed the square and factored the right-hand side is to get the y back by itself. Now this may look a little bit messy, but don't worry too much. What we're going to do is start by subtracting the b squared over 2a squared, so minus b over 2a, quantity squared, from both sides. And we'll end up with y minus c over a equals my x plus b over 2a squared minus my b over 2a whole thing squared. Next I'm going to multiply both sides by a to clear the fractions. I multiply this side by a, the a's cancel, and over here I'm multiplying each of my two pieces by a. So now I have y minus c equals a times x plus b over 2a quantity squared minus a times b over 2a squared. Finally, I'll go ahead and add c to both sides, then I'll have my y by itself. Now, I know this equation can look a little bit intimidating, so let's talk through it. What I have here is y equals a multiplied by my x plus something squared, and then I've got a big number back here. All this stuff in purple is really just one number. That's the y coordinate of the vertex. But what I would like us to look at is to figure out what the x coordinate of the vertex is from this equation. So whenever I had y equals some number times x minus h squared plus k, I knew that the x coordinate of the vertex was that h value there. Let's just write that down again real quick. A times x minus h squared plus k. So this purple stuff that I've highlighted in pink is the value of the k. The a here is the a here, and this b over 2a corresponds to the value of h here. So the x-coordinate of the vertex is negative b over 2a. Notice that I have to adjust by a negative sign there. This is the formula that we're going to use for the vertex. So in order to find the x-coordinate of the vertex of a parabola, you can find the coefficient of the x, b, the coefficient of the x squared, a, and then plug them into this formula, negative b over 2a. Now you could, if you really wanted to, remember this as the formula for the y-coordinate, but what we usually do is just get the coordinate, the number for the x-coordinate, and then plug it back into the original equation to find out the number for the y-coordinate. In the next section, we'll do some examples using this formula.